ln t,
Mm-hmm.
and then 3et over 7. Well, 3t stays as 3t, but over 7.
Sorry?
Is it just the same?
Yep.
3 over 7?
Yep. Exactly the same. Whichever way you want to write it. Got it. Any questions about those? So let's see. This is different notation. Same idea. How would you do 3c?
Where's that? Okay. So 2e2 of 1. So shall we separate it or not?
Mm-hmm.
So 2e2 over 5 times 1 over 5?
Plus 1 over 5.
Oh, no. Yeah, and then that stays the same. The 2e2 over 5.
Mm-hmm.
And the 1 over 5 goes to 1 over 5t.
Mm-hmm. D.
So we split it, so you get 3y over y plus 1 over y. The 3y over y, is that the same as 3y minus 2? Is it not? I don't know.
Simplify. 3y over y.
Oh, so just 3.
Mm-hmm.
Yeah. So is that just 3, or do you integrate that then?
And then integrate it.
So 3, and then that'll be 3y. Okay, and then plus ln modulus y.
Yes. Plus mod y. And how would you do f?
I don't know. Is there like a rule or something?
There's an easier way.
What, like expand out the brackets first, or?
Yeah, and so we don't need to do it. You would literally just expand the brackets and then just integrate as normal. And that is with respect to x. And then you would just go about it normal way. Any questions there?
So how many answers would you get for the last one?
How many, what terms?
Yeah, terms. 4.
Well, if you're expanding a double bracket, you usually get 3.
Mm-hmm.
You might end up with 2. Might simplify down.
Okay.
This one.
Passes through the point. Given that f dash x is 2x minus 1, the final expression for x. That's a fancy way of saying integrate.
Mm-hmm.
So 2x minus 1 squared. So do you want to expand it first and then?
Mm-hmm.
Okay. So once you simplified it, you get 4x minus 4 plus 1 over x, and then you just integrate that.
All over x. Oh, and you simplified that as again. So 4x minus 4 plus 1 over x.
And then you get 2x. Well, actually, no, you get 4x squared over 2 minus 4x plus ln modulus x. And then you can simplify the 4 over 2. Yeah. Oh shit, the plus C. Hate.
How do you deal with that? How do you deal with a plus C? What number was it?
The y passes through the point 1 minus 3, so 1. Oh wait, no, sorry, minus 3.
Y is minus 3.
Yeah.
X is 1.
Oh, actually I have to work out the C down. So minus 3 equals 2x squared minus 4x plus ln x plus c. X equals 1. How many marks is this?
Not many.
Then they should have just told me to do that. Oh, how do you get modulus on this? I think it's random. And then 1. So minus 3 minus 2 gives you minus 5. C equals minus 5.
And so what's the f of x equals it?
Two x squared minus 4x plus ln modulus x minus 5.
Yes. Any questions about that?
No.
Okay, so when it was differentiated, the minus 5 became 0. And so when we integrated it, we had the plus c. Because they gave us 1 point, we were able to recover where it was. How do we do these?
All of them?
In general. Let's say second one, B.
Same thing, but then you just put the numbers in. So t plus 1 over 2. So we integrate that first. So we get t squared over 2 plus ln modulus t. And then we put the numbers in. So and then you minus them from each other.
Yeah.
Oh god. What'd you get? Have you worked it out?
No.
Oh. I got 11.4.
Exactly?
I don't know, if I have messed up my calculator, I'm surprised.
Okay, so they have 21 over 2 plus ln 5 over 2. So I'm sure that that's the same thing. And so they didn't ask for an exact answer though, so we don't need to worry about it. If they ask for an exact answer, you might have to leave it in terms of ln.
Yes. Okay. Yeah, okay.
And you're aware of I don't know about your fancy calculator. on the less fancy one, you can just press the integral button for numerical stuff.
Oh yeah.
So it won't be.
So 5, 2, and then x squared over 2.
No.
Oh wait, no, you put the other thing in, don't you? Yeah. What was a normal thing? X plus 1 over x. Yeah, same thing.
Okay. Yes. So all of these I'm happy with. Then you can leave them as exact solutions if you have to. You can get them there. How would you find the area in question 6?
Use 0 and 2. Integrate and then.
Yeah, 2 and 0. The bigger number
Yeah,
is always
2
on
and
top.
0.
That's fine. Those are fine. That's fine, I think. I'm going to leave that. Okay, good. Good. That is, let me just check. Okay. That's A. B. Okay, how do we do this one?
Which one?
A.
It's 1 over 8, x minus 2, 8. To the power of 8, sorry.
Wait. Say it again, sorry?
1 over 8, x minus 2 in brackets to the power of 8.
Eight. So it's 8 plus C, yep.
Let's see.
B.
1 over 6, 2x plus 5. Oh no. 1 over 8, 2x plus 5 to the power of 4.
To the 4 plus C.
Plus C. Damn it! Oh.
1 over 8, 2x plus 5 to the 4 plus C. So you're good for these. How would you go about F?
It's 1 over. It's minus a half, x plus 7 to the. Oh no, damn it. You convert that to x plus 7 to the power of minus 2, add 1 to that, so you get minus 1, so it's 1 over minus 1, so it's minus x plus 7 to the minus 1 plus c.
I'm sure that's fine. So this next one is similar. And then how would you go about the last one? H.
So that's the same as 2, 5 minus 3x to the power of minus 3.
Say it again, sorry?
I said that's the same as.
No?
Oh, it would be a half.
Yes. Because of bidness. And then you just do it the normal way.
Yeah.
Okay. So that is that one. Let's see. Yeah, I think you're fine. And there's a point. So with each of these you get a plus C and then you sub that in to get C. That's okay, I think. In between those limits, yeah. In between there, yeah. Okay. I'm happy. C. How do you do partial fractions?
Um, 3x plus 5 equate to a brackets x plus 3 and b brackets x plus 1
And what's in between the two fractions?
plus.
Yeah.
So then you get ax. Then you get 3x plus 5 with 3 line things goes to a x plus 3 plus b x plus 1. And then I do the substitution method.
Okay.
So if x equals minus 1, then 3 times minus 1 is minus 3, minus 3 plus 5 is 2. So 2 goes to minus 1 plus 3 is 2, so 2a. So a equals 1. And then if x equals minus 3, 3 times minus 3 is minus 9 plus 5 is minus 4. Minus 4 goes to minus 3 plus 1 is minus 2b. So b 2. So then, yeah. And then hence.
Oops. And so A was 1, was it?
Yeah.
Yeah. And B was?
2.
Okay. And so partial fraction form?
So x plus 1 and x plus 3 goes to 1 over x plus 1 plus 2 over x plus 3.
Part B.
So 1 over x plus 1 is the same as. Oh wait, isn't it? Can you separate that and then just do it like that?
No.
Or is that not allowed? I'm not allowed to do that.
No.
Why not?
You're thinking of if there's one thing on the denominator and 2 on the numerator, and you can separate them out.
Yeah, so that's the same as x plus 1 to the power of minus 1.
Mm-hmm.
Then you get minus x plus. Oh wait, no, it goes to 0. Oh, how do you do that again?
The integral of the first one is ln magnitude x plus 1.
Oh, okay. ln x plus 1. And then the second one. Forgot how we did that. So 2x plus 3 to the power of minus 1. Then you add. Oh, I don't know how to do it. Oh, wait, no. It's 2 ln x plus 3. Right? No.
Yep, modulus x plus 3 plus c. So you do partial fractions first, and then you do that second. Those are fine. Integrate with respect to x. Only if I was to find, I'm just going to use the answers rather than doing the partial fractions bit. So worksheet C, answers. So question 2 in 4. Okay, I'll just take in a few of these. So that's that one. Okay. Let's take a look. Okay, how do you do top left?
Top.
Let me just check. I just want to check the previous one for a sec. Yeah, it's fine. How do you do top left?
Is it like? Is it just a 4ln? It has to do that. 4ln modulus 2x plus 1.
Before you feel too good, what is the derivative of 2x plus 1?
2x squared over 2. So
that's the integral derivative of 2x plus 1?
2.
And so that's the derivative of the function inside the function.
I don't know what they mean.
So I believe it would be times 1 over 2.
Why?
It's like with the brackets. Here you had one, the question B. It would have been, hang on. So that is, yeah. So this, why was this 1 over 8?
Because the rule was 1 over the new power times the thing in front of the x.
The reciprocal of the derivative?
Yeah.
Okay, so you did 1 over 4 times 1 over 2 to get 1 over 8?
Yeah, but that's because I remember the rule. What's the rule for this?
And so this is like the bracket. And so it's 4 times 1 over 2.
Okay. 4 over 2x plus 1 goes to half 4 times 4 ln 2x plus 1. So half times 4 is 2. 2 ln 2x plus 1, and the other one is 1 over x minus 3. So it's plus ln x minus 3 plus c.
Yeah. How about the one underneath it?
So 2 ln x, or 2 plus x modulus, because there's no like thing in front of the x. Plus is 2 ln modulus y minus x plus c.
What is the derivative of 1 minus x?
Oh, so it's minus 2 ln x.
Yeah.
1 minus x. Damn.
And bottom right.
Oh my god. Ew. Don't want to do that for minus, like. So that's over x minus 2 minus 3 over 2 5x minus 4. So a half over x minus 2, isn't that the same as 1 over 2 x minus 2?
Sure.
I don't know how it felt for me, but
Just leave it as a half.
yeah. So alright. So a half over x. So do we times whatever we, so do we do like, did you have to times that by 2 or something?
Why would you times by 2?
Oh, we'll have to do a half ln.
Why not?
I don't know. I just didn't think that was a rule. I thought the rule was like. Okay, so half ln x minus 2 minus, what is that? I can't remember writing. 5, that's 5. And then 3 over 2 over 5x minus 4. So 3 over 2 times the 5.
That would be if you're differentiating, integrating.
Yeah, but like 1 over,
Yes.
over that.
So
Over 2 times 5 is 2 over 15.
okay.
Oh. 3 over 10. So minus 2 over 15 ln 5x minus 4.
Don't forget it.
Let's see.
Yeah. Got it. Any questions about that? Okay, so let's see. We did that. Coefficients. Yeah. Okay, integrate.
So 2 over x plus 2 is just 2 ln x plus 2 modulus minus, and then it's minus ln modulus x plus 1. And then you do. Ooh, that's a sticky one. I don't really know. 2 over x plus 2 minus 1 over x plus 1 minus 2 over x plus 1 squared. So we got 2 ln x plus 2 minus what did I say? Minus ln x. And then the minus 2.
Nah. So that's the same as 2x plus 1 to the minus 2.
Times 2. Okay. So that's the same as 2x plus 1, so minus 2, and then you increase that by 1, so that. Oh, what happens to 2? Is it just minus 2x plus 1 to the minus 1?
Yeah, and it was already minus.
So plus.
Yeah.
Plus 2x plus 1 to the minus 1. Sure, that doesn't seem right. Oh well.
So the minus 1, you could write it as 2 over x plus 1. There it is, 2x plus 1 to the minus 1. And you have the plus c. That's all good. Let me just see what we've got here. Yeah.
Oh, that looks wrong. I don't know. I was looking at the left, not the right. Okay, so 3 over 3 minus x gives you 3 ln, oh no, minus 3 ln modulus 3 minus x. And then you get minus ln 2 plus x. Well, I have no idea. 3 ln 3 minus x. Yeah. And then you do the same as we did before. So 2 is the same as 2 plus x minus the power of minus 2. So you get minus 2 plus x to the power of minus 1. Oh, that's a plus. Plus 2 plus x to the power of minus 1.
That's it. Any questions there?
Nope.
Okay, good. And you remembered to do the integral, like the chain rule thing in the middle, so that's good. Which tells me you'll be fine for the others. So if anything, those are okay. So doing it for definite areas, definite integrals, I assume you're gonna be fine. Yeah. 2x plus 1. So this is 2/3. We did the fraction thing. And then that's it. Good. That's C. D.
Oh, God.
Yes.
Which one?
A.
2 cos x integrates to 2 sin x, half sin x.
You're thinking of if it was cos 2x, because then it would be a function inside a function.
So what is it, 2 sin x?
What is B?
B minus a quarter cos 4x.
Yes. So that tells me a lot. Okay, C.
Why did you guess that? C, if it's cos half x, then that goes to half sine. Nah. If it was sine 2x, you do a half. So, 2 sine half x?
Well done. Let's see. Okay. How about D?
So sine ax plus b. So 1 over.
No.
Oh, I have no idea then.
You do.
Is it? No. That's ax plus b. That's the form of ax plus b, but I have no idea what the rule is.
So it's the same way it did B.
Quarter.
Oh. What is the...
I don't know what b is. What's b? Minus. It goes to minus cos.
Yeah.
X plus pi goes to minus cos. Is it just the same?
That bracket's the same. Just like the way that was 4x, that was a half x.
Yeah.
And what is the derivative of x?
1.
Derivative of pi over 4?
Nothing. Z plus C.
And so it's just times by 1, so it stays the same. E.
E. Minus sine.
Not minus.
Damn, when did we do? Oh, okay. Sine cos. No. Sine 2x minus 1.
What is the derivative of 2x minus 1?
2.
And therefore?
Over 2.
Yeah, everything over 2 or a half sine 2x plus 1. 2x minus 1. F.
So 3 minus 3 cos pi over 3 minus x, and then the derivative is minus 1. So does it become positive?
Yeah. Any idea about G?
Where is that? Sec x tan x. Sec x goes to
Formula sheet for G. Formula sheet for H. You'll need formula sheet for I.
Oh, they're all formula sheet. I thought we have to learn them.
Nah, formula sheet.
Are you sure?
Sorry?
Are you sure?
Yeah. Right.
I don't know. Just gonna check.
You let me do this stuff.
No, it's fine. I can do it. Just formula booklet. A level. Tells you what it differentiates to. Oh yeah, so sec x tan x goes to sec x.
And so, answer for G?
Sec x.
So that's sec x plus C.
It tells you like 4 of them.
H cosec.
Oh god, it gives you loads. I don't know how to get back onto you. Oh yeah, hang on. That one. Which one are we on?
H? No. Well, H. This is I. No, H, yeah.
H. Cosec squared x. Oh, that's cosec kx. Cosec x squared x is the same as cosec x to all squared.
Mm-hmm.
Don't know how it helps, but. And then we said that minus 1, so it's minus ln.
No, it's not. You'd add 1 to the power.
Yeah.
And what do you do with the new power then?
So it's cosec x power 3.
Yeah.
So is it 1 over 3 cosec x to the power of 3?
So it's gonna be 1 over 3 cosec squared x, whichever way you want to write it. But you actually have to get the derivative of cosec x, don't you?
Yeah.
Derivative of cosec.
Cosec cot x. So minus cosec cot x. So 1/3 minus cosec cot x. To 3.
Yeah, cosec x cot x. And actually, go on, so what is the thing?
1/3 cosec x cot
No,
x.
I believe you divide or times by 1 over the derivative.
What?
So don't we always do times 1 over it?
There is no derivative.
I'm looking at the derivative. The derivative of cosec kx is this.
Oh, so 1 over cosec cot x. Oh yeah, derivative is differentiated. Wait, no. Cosec differentiated gives you that. Or cosec integrated gives you that.
Differentiated.
So 1 over 3 cosec
Yeah, I'm just going to make it one fraction.
over 3. Where'd you get cosec squared?
I just multiplied across.
Oh.
So that's 3.
Cot cosec x cot x.
Can you simplify?
Cosec x 3 cot x.
Yes. Any questions about that?
No.
Cosec x over 3 cot x. Let us now do I.
Cosec quarter x cot quarter x gives you 1/4 cos. What was the rule?
Hold on. Are you doing I?
Oh, I. 5 sec squared 2x. What was the rule?
You for what? What am I looking up?
Sec. Sec squared. Sec.
So there's sec kx. Hold on.
No. It goes to k sec squared. Kx goes to tan kx. That one.
So that kind of has both, but let me just sec squared. Is this sec squared? Yeah.
One over so 5 times 1 over 2 gives us 5 over 2 sec. No, 5 over 2 tan 2x. Or that, if you want to do that.
Why is it 5 over 2?
Then you do the 5 times the. Well, it's 1 over k. K is 2. So don't you. Where does the 5 go?
Add 1 to the power.
3.
What do you do with that?
But that rule doesn't say add 1 to the power.
You are integrating, so you're always adding 1 to the power.
Yeah, but on the right, the last rule.
This one over here?
Yeah. That is that integrated, isn't it?
Okay. You're onto something. That's too easy. Oh, wow. That's exactly right. Okay. That's... Alright, so what's the answer then?
I don't know now.
5 over 2.
Sec 2x. No, tan 2x.
Well, that's ridiculous.
But then where does the squared go? Oh, wait,
I
that
don't
is
see a
that.
squared.
Yeah, yeah. That is that. Yeah, okay.
Okay, and let's see. So J would match up with cosec x, cot x,
That one there.
which is there. And so working in reverse,
Cosec quarter x.
I think it might be minus cosec quarter x. I'd have to look it up because it was negative. But we should use the I was using the differentiation formula in reverse. You would use the integration formula. This is worksheet C. And yeah, we did well. Oh, hang on a second. One question. Worksheet C. Now that we were on worksheet D.
Yeah, we want D. Question 1. No, question 1.
Towards the end somewhere. So 5 over 2 tan 2x plus e, and then minus 4. We forgot to do times by 1 over 4. So minus 4 cosec quarter x plus a. Okay, so we would just use the proper formula. Yeah, how was that for you, Saba?
Good.
Anything in particular you want to do next time? Continue differentiation or something else? Oh, sorry, yeah.
Yeah.
Okay. Any questions for me in general?
No.
All right. Well done, Saba. You did great. I look forward to talking again next week.
Bye.
Have a good week. Goodbye.